All right, we left off in section 9.3 last time. We were looking at some applications of probability, and in particular, the one that we were looking at last was expected value. And if you remember, this is our formula for expected value. What we do is we take each of our outcomes, whatever they are, and these are numerical valued outcomes. So I did an example of like deal or no deal where they have the different cases with different dollar amounts. Those would be the outcomes, the dollar amount you would win. And then they multiply it by the probability that you have that outcome. And so you might have just two scenarios, or you might have more. So I gave an example of a roulette wheel one, where on the roulette wheel, you either win or you don't win, based on this particular way that my father-in-law likes to play, where he bets on zero or double zeros. And so when we looked at this, we talked about the expected value as the amount that you would win, and then multiplied by the probability that you would win, and then the amount that you would win, quote unquote, which is really losing because it's a negative number, right? Times the probability that you would lose. And this ends up costing you $1.05 over the long haul of playing this game. And then the deal or no deal one right here, in neither scenario are you really losing, although I would contend that if you got the $10 case, you would feel like you lost, right? So those two happen to both be positives. You either win $10 or you win $250,000. And then it's a 1/2 because there's two cases and it's equally likely. And we talked about the fact that we could have done this on an earlier sort of stage in the deal or no deal game, and we would have done it exactly the same way. We just would have had maybe 5 outcomes that we would have had to consider, or 10 outcomes, or 30 something. What does it start with, 36? I don't even remember, something like that. So we could look at all those outcomes and we can find expected values. All right, so the way we're going to look at today is going to be a lottery. All right, so we're going to take a given lottery, and the odds of winning the lottery are 55 million to 1. That's really bad, just so you know. Like, you're not going to win. That's really what that says, okay? But the first question asks then, what is the probability of winning the lottery? Now, we talked about how odds and probability are connected last time as well. Let me go back real quick and remind you, since this is our first question about it. When we're finding probability of an event happening, we have the odds are right here, actually, M to N. So M is the number of outcomes, and N would be the number of wins, or vice versa, depending on whether you're talking about for or against down here. And so you're going to take the number of ways that you win. That's the numerator. In our case, how many ways can you win on the lottery? It said 55 million to 1. So how many ways would you win? One way, okay? So when we're looking at probability here, sorry, just a sec. So the probability of winning, we'll say winning, is 1 out of how many? How many different ways? It's still a big pen.
55 million?
You're really close. It's not 55 million, but
54.
no.
54.
55 million, 1. Okay, so let's go back up to odds. I know this has been like a week and a half for those of you who had watched it or did it in real time with me last time. 55 million to 1 means that there's 55 million ways that you would lose and 1 way that you would win. So there's 55 million and 1 ways that this could actually happen. So that's why the denominator gets those two numbers added together. And you have to be careful. It's 55 million to 1, so that's not 56 million, right? It's millions, and the other one's in units, individual units. So it's 55 million, 1 in the denominator. So this is the probability of winning. So let's take a look then at Part B. Part B says, if the grand prize is $14 million and a ticket costs $5, is the game fair? So we talked about this phrase, fair game, a game being fair last time. I meant to underline it. Do you remember when it said that a game was fair? If not, go back and look through your notes and see if you can find out where it said, or when it said a game was fair. When is a game fair? Do you know what, Kier? Yeah. If the expected value, we use a capital E for it, is equal to 0. So it means you're just as likely to win as you are to lose. That's what it really means. That over the grand haul of the entire time, you neither win nor lose. That's what expected value is calculating for you. So if you're looking at the expected value for this, and you want to know if you're looking for where the game is fair, or if the game is fair, you're looking to find the expected value. Okay? So expected value in this case has one of two outcomes. You either win or you lose, right? And we talked on the deal or no deal question that it doesn't really have to end up being losing, but in this case it is. You either win and you win the 14 million, or you lose and you just lose the money you gave toward playing the game. Make sense? Okay, so we're going to calculate expected value, and you will need your calculator for this in a moment. So we're going to have the amount of money that you win times the probability that you win. And then this is the amount of money that you lose, so it's a negative number when we get there. And we want the probability that you lose. Okay, does that make sense to everyone? This one happens to have two outcomes. You're going to do some in your homework that have 3 outcomes or maybe more. All right, so if you win, how much do you win? How much?
Is that 55 million?
Nope, not 55 million, but 14 million. You may win $14 million, almost.
Taxes.
That's a very good thought. Not what I was thinking. Minus your $5 that you paid to play. So yeah, taxes aside. So we don't really win $14 million. We win $13,999,995. Are you with me? Because you paid to play. All right, so you win $13,999,995. And what is the probability that you will win? Right, it's the value we got from part A, right? So it's 1 over 55 million, 1. Okay, so far so good? If you lose, how much do you lose? $5. So it's a negative 5 because it's a loss. And what is the probability that you lose? We haven't calculated that yet. Yeah, that's right, Sadie. 55 million on top over 55 million, 1 on bottom, right? All right, so what we're trying to figure out is if this actually gives a fair game. So you're going to calculate, multiply these things out. If your calculator can tolerate it, multiplying all of it out in one long string is actually preferable here so that it doesn't round things inappropriately along the way, potentially. And what your expected value is a dollar amount. So whatever you get is a dollar amount coming out of this, so you need to record it that way with 2 decimal places and so forth. So what'd you guys find?
Got a negative, but I don't think that's right.
It is supposed to be negative, actually. You're right. What'd you get, Timmy?
49.74.
That sounds too big.
Okay, because I got the same thing. Negative 49.745, 45, 3, 7, 3.
I got negative 4.7.
What'd you get?
I got negative 4.7. I guess I'd be fine.
Yours is the answer that I have written down. So I'm going to write down Matt's answer, and then I'm going to have you guys double check. Matt, what did you get?
Negative 4.75.
Okay, this is the answer that I have written down. So everybody double check. Be careful with parentheses if you're using parentheses that you open and you close appropriately. That's a really common place for mistakes to be made. Make sure that the negative is in the right place. If you prefer, instead of the negative being here, you could put a minus sign out here and make it just a number right here. Ignore the sign and just put a minus right there if you prefer. Okay, did anybody else get 475 at this point? Nellie did. Danielle did. Okay, sounds like we're good. Beth Ann, sorry. Because you keep changing your name on your papers when you turn it in. It's okay. It's all right. It's just, it takes me a sec. So did it work out?
No, I'm.
Demi, did yours work out?
Well, I did it again. I got 499, so it may work.
That's not good. Okay.
I'll try to
But I
break it
believe
down
you.
a little bit more.
Okay, see, yeah, you might need to because yours is a scientific calculator. Demi, what kind of calculator are you using? A scientific calculator. It may not like all the parentheses you're trying to put into it. So if you have a scientific calculator wanting to be careful about the parentheses, what you could do is you could calculate each of these separately. So if you calculated this value, and I would write it down with probably 3 or 4 decimal places for now, and then I would do this value over here, and I'd write it down with the 3 or 4 decimal places, and then calculate the subtraction of the two. That might be a way to kind of break it apart just a little bit to avoid some of the errors that can occur. It should be negative 475. So the first thing that we're going to address is answering the question of, is the game fair? No, the game is not fair. So this is saying that if you bought enough tickets, right? If you bought enough tickets, that you would expect on average to lose $4.75 per ticket. Does that make sense? Okay. But what's the real deal? Well, with many state lotteries, they like to talk about that the proceeds go to benefit education. Have you heard that before? It's one of the big proponents that people like to use for lotteries, actually. And there's a lot of weird things that are associated with this. We're just looking at the mathematical part of that argument right now. So under these conditions, if all of the proceeds benefit education and 1 million tickets are actually sold, what is the expected value from lottery sales? So the expected value of one ticket was $4.75 negative, right? And if it's negative to the consumer, the person who bought it, then it's positive to the state who sold it. Does that make sense? Okay? So what we're actually looking at is we're looking at that $4.75 and we're multiplying it by this number that's 1 million because they're selling 1 million of these. So if they've sold 1 million tickets at $4.75, how much money is that they've, made? Mm-hmm. 4,750,000. That's right. So that's exciting. The problem is that that's not really the way that this is going to work. One of two things happens. Either nobody wins, and then they actually get $5 a ticket. Shake your head if that makes sense. Or somebody wins, and they're out how much? How much do you win if you win? 14 million. So there's really two outcomes. So outcome number one is that no one wins. And if no one wins, then what we really have is we really have $5 a ticket, and we have 1 million tickets sold. And there's really $5 million that's made for the state for education. Okay, does that make sense? That's one possibility. The other possibility is that someone wins. And you could argue, well, because there are lotteries where multiple people win, right, when you choose your own numbers and those sorts of things, but they still only split the pot. So if somebody wins or multiple people win, it doesn't change the numbers, okay? It's still 14 million. So they take in $5 million, right? And then they pay out $14 million because that's how much you make when you win. And then what happened? What happens if someone wins?
They lost $9 million.
Yeah, the state lost $9 million. So it's a really weird argument, right? Like, are you super excited about the lottery because it's going to make money for education at the expense that everybody who buys is going to lose? Because that's one stance, right? I'm just going to, go and take money from everybody that decided to play this thing, right? But I'm going to root for them to not win because then education gets it. Or do I root for somebody to win, and by doing so, it actually ends up costing the state the money instead? It's a very fuzzy, weird sort of situation. Don't you agree? And the same thing happens when you look at casinos in certain places where they will create access for casinos to operate with the benefits to education. That's what was happening when we were living in Ohio, is they kept bringing before the state every time they could the ability to have extra casinos with the money going toward education, because it's really hard to say, no, I don't support education, right? It's a really tough, tricky thing. So they like to use that one as a reason for doing the different kinds of gambling opportunities.
So my parents work for the lottery. I don't quite understand how it works. So if somebody doesn't